All right, the reason we're talking about standard form, it's another way of writing the equation of a line. When we write equations of other things, so in geometry, you'll talk about the standard form of the equation for a circle. In Algebra 2, you might talk about the standard form of the equation of a parabola. And if you go further in math, there are other shapes that all have standard form, and they look kind of like this. So the standard form of the equation of the line looks like ax plus by equals c. So it's different than slope-intercept because we can't tell what the slope is. We can't tell what the intercept, the y-intercept is right away. We'll be able to tell after we do something. We don't know a point that the line goes through, so like point-slope form, we can pick out a point that's on the line. We can pick out the slope easily. Standard form is a little different. Well, what's nice, what's useful about standard form is we can find the intercepts of the line. So the y-intercept of any graph is where it crosses the y-axis. Where it crosses the y-axis is when x equals 0. And the x-intercept is where it crosses the x-axis. And that's true for any graph. And that is when y equals 0. And the x-intercept and y-intercept are very easy to find when our graph, or when our equation of our line is written in standard form. So let's look at an example to see. So let's say we want to find the x and y-intercepts of the line 2x plus 6y equals 18. Well, to find the x-intercept, y equals 0, so that means this whole thing goes away. So we can think of covering up that whole thing. So let me do something here really quickly. Make this bigger, a little bigger. So we cover up that whole thing. Y is 0, so that part goes away. And our equation becomes 2x equals 18. So I divide by 2, and I get x equals 9. So I'm thinking of covering up the y part to get the x-intercept. I could write this over here. Cover up the y part. So to get the x-intercept, I'm covering up this part, and I get 2x equals 18. Now I want to emphasize that this is the point on our graph. This is the point 9, 0, because y equals 0. And to get the y-intercept, well, the x is 0 at the y-intercept. That's what we set up here. Well, that's like covering this part up. And we get 6y equals 18. And we divide by 6, and we get y equals 3. So we can think of cover up the x part to get the y-intercept. I'm just thinking, well, this whole thing goes away. So I cover it up, and I get 6y equals 18. And this is the point, if we think of an ordered pair, 0, 3. The x is 0 at the y-intercept. So we set up here. And then we can use these if we want to sketch a graph. It's nice because now we have 2 points on the graph. So let's sketch a graph of this line. Here are my axes. And I need 1, 2, 3, 4, 5, 6, 7, 8, 9. And I need 1, 2, 3. The point 9, 0 is here. That's the point 9, 0. The point 0, 3 is here, over 0, up 3. And then I can make my line by connecting those 2 points. Whoops, that was a bad alignment there. There we go, that's better. And there's a graph of that line. I don't need to find the slope. I found the y-intercept. But I also found the x-intercept. That gives me 2 points on the line. I can connect those, and I have my graph. All right, questions there? Okay, so I want you all to try this next one. We're going to graph for x minus 3y equals 12 by using the intercepts. So that means we want to find the x, I'm going to abbreviate this, x-intercept, and we want to find the y-intercept. And I'll start my thing here. So you all try this one. Find your x-intercept, find your y-intercept, and sketch a graph. And then we'll talk about this in just a second. So what did we get here for our x-intercept? X equals 3. So to get our x-intercept, we cover up the y part, and we get 4x equals 12. Divide by 4, and I get x equals 3. What do we get for our y-intercept? Y equals -4. We cover up the x part to get our y-intercept. We get -3y equals 12. Divide by -3, and I get y equals -4. Now this is the point 3, 0, and this is the point 0, -4. So if I plot those, 3, 0 is here. 0, -4 is here. And when I sketch a graph of that line, it should look like that. Whoa. Let me make my eraser a little smaller here. There we go. I wanted to just redraw my 3. All right, so any questions on that example? Graphing lines using standard form is actually pretty easy. I think it's a little easier than any of the other ways because you don't have to count the rise over the run to get another point. You have 2 points automatically. That's pretty nice. All right, next thing, vertical and horizontal lines. And we've talked about these a little bit already. Vertical and horizontal lines. A vertical line will always look like x equals a number. So for example, x equals 5. X equals 5 is a vertical line. A horizontal line will always look like y equals a number. Something like y equals -3 would be a horizontal line. And if we want to graph these, here are my axes. To graph a vertical line, x equals 5, we're going to graph a line that goes through x equals 5. So that is the line x equals 5. No matter what y is, my x coordinate is 5. And to graph the horizontal line, y equals -3, we're going to graph, I'll do that one in green, we're going to graph a line that goes through y equals -3. No matter what x is, the y coordinate is -3. So anytime you see x equals a number, that's a vertical line. Anytime you see y equals a number, that's a horizontal line. Now let's remember really quickly, vertical line. What is the slope of a vertical line? Yeah? Infinity or undefined. Because we have rise, but 0 run. We're dividing by 0. When we divide by 0, we get something that's undefined. How about a horizontal line? What's the slope of a horizontal line? 0. Yeah? 0. Slope of a horizontal line is 0. There's no rise. The rise is 0. X equals a number, always a vertical line. Y equals a number, always a horizontal line. Okay, questions there? And we can think of these as the standard form of the equation of a line. This just has no x part, and the number in front of the y is 1. This just has no y part, and the number in front of the x is 1. So we can think of those as the standard form of the equation of a line, just a special kind of line. All right. What if we want to convert y equals mx plus b form? So y equals -3/5 x plus 4. We want to write that in standard form. So we want to change this from slope-intercept form to standard form. Well, we do that by clearing the fractions, or clear the fraction. So in this case, our fraction is 3/5. How do we get rid of that 5 in the denominator? Yeah? Multiply by 5. Now we need to remember to multiply everything by 5. So I'm going to multiply everything on both sides by 5. So I'm going to have 5 times y equals 5 times negative 3/5 x plus 5 times 4. I have to multiply everything by 5. Well, 5 times y is just 5y. 5 times negative 3/5 x, these 5's cancel. 5 in the numerator cancel with the 5 in the denominator. And I get negative 3x. And 5 times 4 is 20. I want the x and y together on one side for my standard form, because standard form is ax plus by, capital B, sorry. by equals c. So I'm going to add 3x to both sides. These are not like terms, so I just have to write it as 3x plus 5y equals 20. So to write a y equals mx plus b form line, in standard form you need to clear the fraction from the slope. And when you clear the fraction, you multiply everything by the number that clears the fraction. The everything part is what students usually forget. Let's look at this one really quickly. The y-intercept here, when I cover up the 3x part, when I cover up the x part, what do I get there? Y equals, yeah? Y equals 4. When I find the x-intercept, 3x equals 20. Oh, I get a fraction for the x-intercept here. Sometimes you get a fraction for your x-intercept or your y-intercept. They don't always come out as whole numbers. So I just wanted you to keep that in the back of your head, that your x and y-intercepts won't always come out as whole numbers. It's nice when they do, but they don't always come out that way. All right, so questions on clearing our fractions. Main thing to remember, multiply everything by whatever number you're working with, sorry. All right, last example. It's a word problem. We're at some kind of fair, and the tickets are 50 cents for rides. So this is, we've either traveled to the past, a very long time ago, 50 cents for rides and 20 cents for games. So we've either traveled a long time into the past, or this is just a really horrible fair. So the tickets are 50 cents for rides and 20 cents for games, and we have $5. We want to write an equation for the situation. So that relates the number of rides and games that we could play. Well, let's let x equal the number of rides and y equal the number of games. Well, whatever we do, the total has to equal $5. Well, the amount that we spend on tickets is 50 cents times the number of rides that we go on. Well, how do we write 50 cents as dollars? How many dollars is 50 cents? Yes. 0.5. So I'm going to say 0.5 x. 50 cents times the number of rides we go on. Well, how are we going to write 20 cents as dollars? Yeah? 0.2. 0.2 times the number of games that we play has to equal $5. Now Now if we wanted to avoid dealing with these decimals, 0.5 and 0.2, what could we do to make this all in whole numbers? How do we get rid of this 0.5 and 0.2? What can we multiply by to get rid of those decimals? What would move the decimal over one place? Multiply by 10. So I'm going to multiply 10 times 0.5x plus 10 times 0.2y equals 10 times 5. Now this would not be incorrect, just if we wanted to avoid these decimals. Well, 10 times 0.5 is 5, 10 times 0.2 is 2, and 10 times 5 is 50. So 5x plus 2y is 50. Either one of these would be an equation for this line. This one would probably be a little easier to graph than this one. All right, questions? Yes. Did you have a question?
Yeah.
Okay.
So, divided by 2, 50, what would you get?
25.
Oh,
50 divided by 2 is 25. All right. Our homework is from section 5.5, page 326, 8 through 28, even, 37 through 40, and 43. And we have about 20 minutes. You can get a lot of this done. You could probably get the whole thing done.